Hello everybody, thank you for attending the speech. I'm really honored to be here. So I'm Alessandro, CEO of Lightstreamer, and I'm going to talk to you today about the real-time web. We'll talk some topics like Ajax and especially Komet, we consider like an extension to the Ajax paradigm. So let's take a look at the menu of this talk. We just have 1 hour, so I will try to pack in this 60 minutes a few different perspectives, viewpoints on this topic. So I will try to touch the surface of the history of push technology, that is Komet. I will provide some theoretical elements just to make you understand what we're talking about from a theoretical point of view. And then I will go more practical by seeing some live examples of Komet technology. And then even more practical by showing you the source code and the development of a very simple Komet application that is a chat. By the way, at that time, I will try to involve you in a sort of interactive experiment with the chat we're going to develop. So all of you that has a notebook, get it ready. I will give you my IP address and you will connect with the browser to the server I'm going to show you to work together on this Komet interactive example. I hope there are enough notebooks here and the Wi-Fi work well. And we'll end up showing some of the main features that an advanced Komet architectures requires to be production ready, actually. So let's get started. Some history. You see here the term push technology. But what is push technology? Well, this term originated in 1996 when the first push technology product was created. It was called Pointcast. Soon after Pointcast, more than 30 players came into the arena, try to provide and sell push technology. Push technology basically is a paradigm aimed at inverting the traditional way of interacting with the web. That is, anticipating the contents that the user wants to see. Traditionally, you go to a web page, you make an HTTP request, and you get some content back. With push technology, you want to send the content before the user asks for it. So the early year of push technology from 96 to 2000 were based on the push of full pages with a pretty bad granularity. That means that you subscribe to some sites and every morning you went to the office and find a lot of web pages that were downloaded during the night, supposing that you wanted to see them during the day. It simply didn't work. 4 years of experiments, but nobody actually cared about having this kind of push technology, and it cluttered all the networks. So in 2000, push technology was completely dead, and Pointcast closed. But around that time, a new breed of push technology arose due to the need for online trading applications that were spreading at that time. You know, banks needed to send real-time data to their users for market quotes, prices, bids, asks. And at that time, to fill this gap, they tended to provide browser-based solutions, but that included applets, Java applets, for the real-time part. As you can guess, in this case, the granularity is higher. You're not going to push full pages anymore, but just small pieces of data to update the content of the page, not the whole page itself. So the first solution, the ones that you see in blue, were applet-based, and they went out of fashion 1 year ago, basically. Now everybody is trying to remove the applet from this kind of push technology. And then in 2000, a new breed, an even more new breed of push technology arose, an applet-free push. Lightstreamer, Pushlets, and Now were the first free framework that provided applet-free push technology. We will show some examples so you will understand from the demo what I'm talking about. But just to anticipate that, it means that you have a very normal HTML page and without reloading it, you see the contents updating in very real time, basically. Then in 2005, Jesse James Garrett, that has a talk a few minutes ago, coined the Ajax term, and the year after, Alex Russell from the Dojo Toolkit invented the Komet term. These are umbrella terms that are very useful to define what we're talking about. They're not technologies, they're just general paradigms that can be implemented through several different technologies, but very, very useful to have a common language, common understanding. By the way, the origin of the term Comet is pretty funny, because you know that Ajax was originally an acronym for asynchronous JavaScript and XML, but it's also the name of a cleaning product. In America, there is another cleaning product called Komet, so Alex Russell decided to call his extension to Ajax Comet, basically. At that time, 2006, several sites were using some form of Komet. Gmail, for example, that delivers push emails through the Komet paradigm. Meebo for instant messaging. Renku for online blogs. And then some open source frameworks arose. Comet-D, by the same guys of the Dojo Toolkit, together with Greg Wilkins by Jetty. And other previous frameworks that used applets updated to an applet-free version like Kotlin. So all of this is aimed at providing the real-time web. So let's take a look at some definition. A couple of boring definitions, then we will go into something more funny. So let's distinguish between sync and async modes from a general perspective. You have an actor, and you have a server. An actor could be whatever, could be a person, could be a browser, a user agent. We talk about synchronous mode, basically when you do a request, and then your user agent is completely blocked, cannot do anything until a response comes back from the server. So this kind of paradigm is stop, start, stop, start, stop, and everything is bound to the interaction with the server. On the other hand, in asynchronous mode, the user agent and the server can interact in a fully asynchronous way. That means the user agent can send messaging to the server, and the server can send messages back to the client without any interruption in the functioning of the user agent or of the server. So we use this definition to show very quickly some of the paradigms that has been used to implement the real-time web. So the very traditional way of adding some sort of real-time to the web was based on page refresh, of course. Here you can see three lines. The first one is the user, intended as the person. The second line is the browser, and then you have the server. It's important to distinguish between the user and the browser, because something that is asynchronous for the user could be synchronous for the browser, because the browser lives between the server and the person that is using the browser and can change the paradigm in the middle, as we'll see in a few minutes. With traditional page refresh, everything is completely synchronous. The user refreshes the pages, the browser requests for a new version of that page to the server, and both the browser and the user are blocked. That means they cannot do any more actions during the waiting time for this paradigm. Of course, you can see the limits, the issue. You have a very low update frequency. It's not real time, not even near real time. You waste a lot of bandwidth downloading the full page, and you clutter your web server. Then after the rise of Ajax, the so-called Ajax polling technique arose. You can see the difference. The interaction between the browser and the server is still synchronous, but the browser offers an asynchronous layer towards the user. That means that the user does never see a blocked user interface. They can keep on clicking buttons, while the browser updates the content by polling at the fixed time the server for new data. So under the hood you have the Ajax layer that lives into the browser, that polls the server, and on the other side the user that keeps on updating this sort of near real-time updates. Again, the update frequency is pretty low. The bandwidth is still high, even if lower than before, because now you transfer only data, not the layout of the page every time. But the load on the web server is still high. The advantage, as I told you, is that the user experience is never blocked. After that, Comet long polling was invented to increase the quality of this paradigm. Comet long polling is pretty similar to this one, the traditional polling, but you can see that the polling cycles are not fixed. In traditional polling, every, say, 2 seconds, 5 seconds, 1 minute, you decide, you do a request to the server to retrieve fresh data. With the long poll, you do an HTTP request to the server. If fresh data is available, you get an answer from the server. But if no fresh data is available, the server keeps the HTTP connection blocked, stalled, until some fresh data is available. Only at that time, the data is sent back. Why is this better? For 2 reasons. First reason is that when no new data is available, the client stops making further requests and doesn't use more bandwidth or clutter the server. The second advantage is that when the new data is available, it's sent back at once without waiting for a new polling cycle. The result of this is that you have a very low latency, because to get a new piece of data, you don't need to do a full round trip on the network, request and response. You just have the single trip time of the response from the server to the client. But for a high frequency scenarios, this is still not enough, because for each update, you still need a request coming from the client. And then let's go to the state-of-the-art Comet paradigm that is called Comet streaming. Comet streaming is fully asynchronous. That is, the server can decide when to send updates to the browser at its own discretion, without never waiting for a new request from the client. At the same time, the browser can present the update to the user interface, and during all this time, the user keeps on working and doing what it needs to do without ever blocking anything. The bandwidth is very low, because you just send these small update packets when they're needed. If no updates are available, nothing is set on the network, apart from some heartbeat packets to keep the connection open. So this is basically HTTP streaming, but HTTP streaming that works in a browser without any plugins, without the Java Applex, without even the need for Flash or Flex, just pure HTML and JavaScript as the Ajax paradigm prescribes. So to sum up, so that you can grasp this term, there are 4 models. You can see from a completely synchronous model, that is the first one, to a completely asynchronous model. Other terms that you will find out there in the literature would be for long polling. You will also find the term smart polling, asynchronous polling, Ajax push, or reverse Ajax. These are all synonyms for expressing the same concept. So if when reading article you find these terms, you know what we're talking about. And on the last part, we have Comet streaming, that is also called the Comet forever frame or streaming Ajax. What do you use Comet for? We have a good technology, but why should you need Comet? Well, there are a lot of applications that can take a great advantage from using Comet. The main domain where actually the first implementations of Comet originated is the finance domain, as I told you before. So imagine market data distribution for banks based on this paradigm. You connect a web page and you see the real-time prices coming from the market or the stock quotes without installing any client application, as brokers used to do in the past. And you get quotes, news, your updated portfolio, everything in real time through the internet, wherever you are, even on a mobile phone. All you need is just a common browser. And then the second area is for gaming and online betting. You know, especially in the UK, there are a lot of online betting companies, and you need to see the real-time odds and bets. And Comet is a killer technology for this kind of applications. Then there's auctions. Imagine something like eBay in push mode, that is through Comet. You don't need to refresh the page to see if the price changes, who are the best orders. And of course, all of these companies are working to move towards Komet. So expect all the main sites sooner or later to implement some form of Komet, because the new trend of Web 2.0 needs real time, and Komet is the answer. Imagine then any kind of console. You have a monitoring console for your server or for any kind of application or system. You just want to connect with a browser to the console and see the real-time updates. When sport results, social networks, chats and instant messengers based on Komet, information on transportation, timetables, opinion polls, and only fantasy is the limit for the use of Komet in your application, actually. So let's see some examples for a real grasp. I will show you some demos based on Lightstreamer, that is a Komet framework, and then some real-world applications that are already using Komet. So let's go to Firefox. This is Lightstreamer homepage. This is already a Komet demo. You can see this simple table that is updated in real time with prices that are being pushed from a server located in Italy. So across the internet, HTTP streaming, and the browser displays these in real time based on pure Ajax, so JavaScript and HTML. You see it? This is not an applet, it's straight HTML that gets updated in real time. Let's take a look at a couple of demos. So for example, this is a more extended stock list demo. You see that the user interface is initialized and then the subscription is done. Another key point is that Komet is often based on the publish and subscribe paradigm. So you implement basically asynchronous messages on the top of a traditional protocol HTTP that is based on request response. So this is the trick, transform request response to pub sub. So you subscribe to a list of items and you get the real-time data that is broadcast by the server to all the clients that are connected in this time. You can open multiple windows. You can even have real-time charts that are drawn on the client side based on Ajax, on JavaScript and HTML, again without applets. And the latency you have here is just the time that the TCP packet needs to reach the client starting from the server, actually. Let's take a look at a different kind of application. I talked before some Wi-Fi problem, I was sure. Okay. For example, let's change the domain. Sporting. This demo shows a real-time console for Formula One telemetry. Imagine you have all the probes on your car that transmit real-time data to the boxes and you want to distribute them over the web. In this case, you can see them in real time. Just notice the update frequency. You see several changes in a second. This high frequency is not possible with Ajax long poll because you have a full round trip. Only with pure streaming you can achieve this sort of rate. So depending on the kind of application, you can also decide which is the best paradigms that fit your needs, basically. And then, just another one. I was talking about a console. This is a console of the server. This is Lightstreamer server sends its own status over the web. You can see the free memory, how many working threads you are, the current bandwidth, and the full log. These are real users that are connecting to our demo server, and through Ajax Comet, the page gets updated in real time. So you don't need a thick console to install, you don't need a Java applet, just a straight HTML page, and you see all the information in pure real time. Now let's move to a couple of real sites. Hedge Street is a Silicon Valley-based company that provides a full exchange, and they make use of Komet to update the prices. But now it's American time zone, so we cannot see any real-time prices. So let's go to this other one, IG Markets. I took the Singapore-based version. They have sites all over the world. Let's authenticate. It's a very great. a really great example of a state-of-the-art Ajax application based on the Yahoo toolkit. I will show you something. With a login, and usually Komet is complementary to Ajax. That means you use your favorite Ajax toolkit, and then you add Komet functionality through a Komet framework. So you're not bound to use the widgets or the user interface that is provided by the Komet framework, but it's very specific functioning. So you see some FX for foreign exchange market in real time. You can change their display, for example, in pairs. You can move the windows around. All the traditional feature of a good Ajax front end that you know, but with but adding real-time data flow that shows this. If I go to my watch list, for example, I want to see the Indian index for the stock. I navigate here, I go to other Asian, and I choose India 50. I add it to my watch list, and it gets subscribed at once. I can display it with different views, and the prices, again, gets updated in real time. So you can see how the paradigm is really changing. Real time is possible within a very normal browser, actually. So another interesting one, because by looking at real-world application is the best way to grasp this. Unu is a pretty cool site. It's another American startup, and they decided to create an exchange, a market for sports ticket. So you buy a ticket for your favorite match, for example, and you want to resell it on the internet, find who wants to pay more to buy it, but following the rules of a finance market with 5-level books, bids, asks, and they integrated Komet. So you see here a ticker with prices that are updated in real time for Komet. You can drill down to a specific match, and you can see in some cases even a view of the stadium to choose the seats, the better seats. Here they implemented the Flex component only for the charting part, but it's pure HTML and JavaScript. So if you submit some new order, you see it in real time changing here because it is pushed back to the client without waiting for a new request. And ExtraBet is a betting portal. It's based in the UK. You have all the kind of sports, even politics. You can place your bets, but you need to see the results in real time. So let's try with something that is in place soon. But since it's based in Europe, I don't think there are connected users at this time. But let's give it a check. The Wi-Fi assistant is NSW against Queensland. The prices got updated in real time. If you put an order, everybody will receive it in broadcast mode. Okay. So let's move to the more practical part to see from a source code perspective how a Komet application is done, basically. So we will see this Hello India chat, very, very simple application. And first, how do you implement a Komet solution? You need a Komet framework that basically provides a Komet server and some APIs that you can use to develop it. Of course, I chose Lightstreamer because I work for them. And I will introduce the architecture so that you can understand the source code, basically. So the architecture sees the web server that is kept. You already have a web server, of course. You have your web application with some framework to build your web pages on the server side, JSP, ASP, PHP, whatever, some portal frameworks. You have an application server. Well, you don't need to change anything of this. You just add a new component. In this case, it's Lightstreamer server. You put it in the DMZ close to your web server. And what happens is that the web browser will keep on downloading all the static part of the page from the web server. Nothing changes. And then it connects back to the push server, Lightstreamer server, to issue the subscription to the real-time data that it needs to get back. And that's all. There's a full separation of concerns because web servers are not optimized for doing Comet because the underlying paradigm is completely different. You need to keep a permanent connection open for a long time. So the best approach, in my opinion, of course, is to completely separate the two parts. Web server for everything that is static, push server for everything that is dynamic. How do you push your own data inside the server? By writing adapters. Through the data adapter, basically, you implement an interface, can be based on Java or .NET, and you inject all the real-time updates that you want. Through the metadata adapter, you can control security, permissioning, the quality of service like bandwidth, frequency, and all that is needed to provide a good experience to the final user. So for the sake of our demo, we need to provide a data adapter and a metadata adapter. So let's check out some simple code. This is the data adapter. Basically, we implement a Java interface that is called the data provider. We call this class Hello India Data Adapter. I created this with Eclipse that automatically provided some mock-ups of all the methods that needs to be implemented. And then I simply changed the implementation to provide my business logic very, very simple. So every time a new client subscribes to a new item, the item is the smaller piece of information that a client can subscribe to. An item is comprised of several fields that are a schema. So every time a new item is subscribed to, the first time, of course, because all the other users can share the same subscription, this subscribe method is called on your Java adapter. So what we do here, we just check the item name that is passed, and in this case is hello. If this is true, we just remember that the publishing should be active, and we put true to this variable, basically. We don't need the init method. We just use it to keep a reference to this instance of the class. And then we have the unsubscribe method. If we receive an unsubscription for the hello item, we stop publishing it. So in this case, the data adapter is really very, very, very simple. The metadata adapter, on the other hand, is even more simple, and it receives messages that are published on the client side. On the client side, we will take a look at the page in a few minutes. You can send a message by calling the method. This message is sent back to your metadata adapter, and then you can do whatever you want with that message. So in this case, we extend the literal base provider, that is a metadata adapter that is provided out of the box. We extend it to implement the new functionality. We call it Hello India Metadata Adapter. When we receive a call from Lightstreamer server on our code on the notify user message, we receive the user, the session, and the actual message inside a string. So what we're going to do is to use the data adapter to inject this message inside the client. So we go to the Hello India data adapter that we define here. We access a static variable to get it. We access the listener, that is the object that the server passes us in order to send back events. And then we can send back for the hello item this actual data structure. There is a hash map where we put the message field. This is the name, and this is the actual attribute. All of this is pretty simple to implement, of course, if you follow the Java doc for this. So here you find all the documentation of the interfaces. because often you don't need all the functionality. So you just choose which method to implement based on the requirements for your own application. So once you have created these two Java classes, you need to compile them and deploy them inside the Lightstreamer server. So if you download Lightstreamer server, whatever edition you choose, it's a free edition, you will find this kind of structure in your deployment. To deploy new adapters, you just go to the adapters directory. We create a folder for the new adapter set. In this case, we call it Hello India. Inside the classes directory, we put the compile code from the source code I just showed you. And then you have to provide a deployment descriptor for these two adapters. All that I'm explaining can be done in .NET too, because not only Java interfaces, but the equivalent .NET interfaces are provided, so you can choose. Deployment descriptor in this case is very simple. It declares the metadata provider and the data provider by providing the name of the class and some configuration parameters. So it's really straightforward. Once you've done that, you can launch the server. The server is Java-based, based on NIO classes for asynchronous input and output, and this is fundamental for scalability. In fact, in traditional web architectures, like any normal web server or servlet container, you have a strict association between threads and connection. Each time a new connection is being served, a thread is spawned in the Java virtual machine and in the operating system. And this prevents scalability, because after a couple of thousands of connections, your system starts to suffer. So to implement a Komet server, you need to decouple threads and connection. And this can only be done through a data-driven architecture. In this case, with Lightstreamer, we have a fixed pool of threads, say 10, and they can serve an arbitrary number of users, say 20,000 concurrent TCP connection. This is possible through an architectural model that is known as a staged event-driven architecture, SEDA, and it can be only implemented in conjunction with asynchronous input-output libraries that in the case of Java are provided by the NIO libraries. This is the reason why you need some specific implementation and architecture for making a scalable Komet server, and you cannot rely on a servlet to be put inside any generic server container, unless you have just a bunch of users that connect this. So we launched the server. You can see that the adapters we created have been correctly loaded, and now the server is listening on port 80. Because Lightstreamer server, a Komet server, is exposed on the network as a very normal web server. It speaks HTTP. It can even provide pages, static pages, even if it's not optimized for that. But then the trick is to use HTTP to send real-time data. How is this done? Well, in Komet streaming, it is the fourth paradigm I showed you, the client issues an HTTP request. And then instead of responding and closing the connection, basically the server provides a very long-lasting response. Say you push 10 megabytes of content in 10 hours, for example, as long as you can make the connection resist without failing. In the case a new reconnection happens under the hood and the user doesn't perceive anything. But the trick is this: instead of sending an HTTP response, you send a very, very long response. In this case, you reach real streaming, even if HTTP is was not designed for streaming. But it actually works very, very well. So now the server is running. Let's go to the front end to see how the page could look like. So we go again to our deployment. We go this time to the pages directory. You deploy your web pages if you're not using an external web server for testing purposes. In production, you will have your own Apache or whatever. In this case, even the static pages are served by Lightstreamer server for simplicity. Let's start with the first version of the source code. So here, the page is pretty simple. There's some scrolling issue. Let me move it. Okay. Very simple page. Let's see how it appears if loaded directly in the browser, that is from the file system and not from the HTTP protocol. This is the layout of the page. Again, we need to move it. We just want an input field for your nickname and another input field for the message. And you want to see the messages from everybody appear here. So now let's look at the source code, really straightforward. I wanted to keep this very, very simple, just to show the fundamentals. So we just import a couple of libraries in this script, ls-commons, ls-pushpage. Then you use a very normal HTML widget, that is a div, but you add some specific attributes that are source, table, item, and field. These are extensions to normal HTML that are parsed by the JavaScript libraries to use a div as a Comet widget. So we declare that the source for the content of this widget should be Lightstreamer. The table name is hello table. We subscribe to an item called hello, and we want to show a field called message. And we put a placeholder here for this one. And then let's create a very normal form to put the nickname and the message here. When the user submits the message in the chat, this call is done. Window, engine, send message. I show you some code below, where we pass the nickname and the message, and that's all. Then some plumbing code here. To make this a push page, you need to declare that, so you need to create this object, this is called push page. Then you need to create a couple of callbacks on your page. On engine creation is called when the Komet engine is being created. And you use this to configure the Komet engine. You say the adapter name that we want, in this case hello, and then you switch the status to streaming, because we want to work in streaming mode, not in long polling mode. On engine ready is called when the engine is initialized and is already connected to the server, and we save the reference into this variable, window engine. Then we can bind and call the create engine that will call on turn these two callbacks later. The override table is associated to the widget that we put in the page. So we put a div tag. Now we want to say that the behavior of this tag should be override. That is, when you receive a new value, you override the previous one with the new one, basically. You put the snapshot required to have an initial value, and you add the table to the page. And here you can configure some presentation behavior. If you want the cell to change in color for how long, and all this. Let's see how all this appears in a browser. So let's open a new tab here. We connect this time not anymore from the file system, but through HTTP. In this case, it's localhost. I go to Hello India. It's connecting. And now you can see here in streaming mode. I can put a nickname here. Post the message. When I click on send, the message is sent to the server, and the server sends it back to the client. Now, if you want to connect to my own server and interact with me, I give you the current IP address. If somebody has a laptop over there, just in case, it's this one, 192.168.182. Just to show you that we could actually interact in this way. And if you post some message, it's broadcast to all the pages actually everywhere on the internet that are connected to the same page. I cut and paste the IP here and broadcast as a message. Okay. If you want to have a traditional chat view, we can slightly change this front end. Let's go to a second version of this. Okay. Okay. You can see somebody interacting. So let's go to the second version. Instead of Hello India HTML, you can go to Hello India 2 HTML. It's the same approach, but with a different front end that shows the history. So again, we can interact. Send. Yeah. So you're interacting with me. You can see that both this application and the previous version can be opened together, and they all see the same data. I can open in multiple browsers, multiple tabs, and you always have the same coherent state, basically across the world, in a very, very normal HTML front end. You see how simple the page is actually. So how we implemented the second part of this chat, where the updates are stacked once upon each other. The second version is very simple too. Instead of creating an override table, we created a Dyna scroll table. Dyna scroll table automatically creates this kind of data structure, you see. So instead of that div, I provide here a template under the form of a table. So I create a table, tr, I declare the source to be Lightstreamer, I create two TD elements. The first one is just for this red sign. The second one embeds another div tag where I declare that the message field should be displayed. And that's all. Then we have the same pumping logic, and actually works. Yeah, maybe Twitter should use it. Graphical effects, that it gets red and then it turns to black. How to do that? It's straightforward. We just declare that it should last 1,500 milliseconds, the transition from hot state to cold state. And we decided that the attribute should be this color for the hot state. Of course, I can change it to any other color. Let's do a random color. I don't know what's. I just save the page. I just click on reload. And the color changed. It's going from red to blue. It's just a simple example. You have plenty of controls over the aspect of it. But what I would like to stress is that you're not compelled in a Comet solution to use these widgets. Because again, Comet is focused on the transport. You need a Comet server, you need a Comet client library that delivers messages in a reliable way. How to display them, it's up to you. So for example, Lightstreamer provides this visual layer of ready-to-use widgets to display this data. But if you prefer to use the Dojo toolkit, Yahoo, general interface, or anything else, it's straightforward. You just catch this data and use them to display them in your own front end, actually. You can also mix the two approaches. Perhaps you develop a very complex Dojo application, and then just for some real-time messages like these ones, you want to put a ready-to-use widget, that you can do that. You can see some online demos of integration with Dojo, Ajax from Microsoft, general interface, are very open, of course, to integration with any third-party Ajax toolkit and framework. Now, to show you another pretty important aspect of this that has to do with the sharing of connections. One of the typical, yes, Gmail uses Comet in the long poll version, not in streaming mode actually. When you open a connection to the server, it consumes one connection from the connection pool of the browser. So one of the typical critiques against Comet is that after a couple of applications open towards the same server, you cannot navigate anymore because all the connection pool of the browser is completely saturated. In particular, IE7 only offers 2 concurrent connections to the same host. Firefox a bit more, but sooner or later you can reach this limit. So how to solve this issue? Well, in this case, we solved it through sharing the engine. The first application that initialized the Comet engine creates the physical HTTP connection. All the other instances will automatically attach to the existing connection through multiplexing algorithms and will not consume more HTTP connection. So with one single connection, you can host many, many different tabs in the same browser. So let me show you some magic. I open more of the same application. Let's open. I recently made a scalability test with the new Firefox 3 beta. It's really incredible. I could open 50 tabs with the same Comet application streaming at high frequency with less than 50% of the CPU. So now that I open all these instances, they all share the same Comet connection. So if anybody posts something, all the messaging will be broadcasted to here. But the actual connection is present in only one of these. How to know which is the one that is hosting the connection? The one that in the status bar shows Lightstreamer is in streaming mode. That means that this page physically contains the Lightstreamer engine that keeps the HTTP connection open. All the others are slaves of this master, basically. So you will argue that if I close this tab, I will lose the HTTP connection. And actually that's true. So let's try to close it. And you see that all the other tabs got empty. But the magic now is what is called, you see that they're connected again. Magic is called automatic engine migration. So if the connection closes, all the slaves understand that they're disconnected, and they do a real-time election. So some of the other pages will candidate to become the new master push page. All the pages will participate in the election. And when the new master push page is elected, it reopens the connection to the server. All the other pages resubscribe to the items that were currently subscribed to. And the session is completely restored in a transparent fashion without the user having to do anything. So in this case, you can have as many applications you want in the same browser and never worry about the failover because it's completely automatic. Who is the new master page? This one again. So I could go on again and close and wait for the new election until another one is elected, the subscription is redone, and everything comes back. Okay, just want to finish with another couple of more theoretical considerations, theoretical considerations on some of the advanced features that a good Comet solution should have. Bandwidth control and frequency management. What does it mean? Bandwidth control is very important because when you deal with HTTP streaming or any kind of streaming, you risk to saturate the connection if you want to send too many data, especially too much data, especially in the finance field. So with this solution, you can allocate a maximum bandwidth to the streaming connection and let the server filter the data to guarantee that that maximum bandwidth is never exceeded. So you decide that your Comet session should use 10 kilobits per second for each user, or even differentiate the bandwidth for each specific user. You have a power user, you want to give them more bandwidth. You have a free user, you want to give them less bandwidth. You can do that by bandwidth control. But how can you filter data? Well, it's all related to the nature of the data. There is some kind of data that is naturally filterable, other that isn't. For example, market prices. If you have the Microsoft stock quote that performs 50 prices in a second when the market is very active, of course you don't want to push all the 50 updates to the client in a second, because you clutter the network and the human eyes cannot perceive them. So you are going to filter them. You decide that you want the most 3 updates in a second. You allocate a maximum frequency of 3 updates per second, and the server automatically filters them. If in the same page you have an item that updates very fast and another item that updates once in an hour, of course you cannot lose that single update that comes in an hour to display the updates for the other one. So you need some good smart algorithm on the server side to decide how you can filter and what you can filter. And this usually is done by declaring the kind of data, if it can be filtered or not, and assigning some attributes to this kind of data management to fully match the requirements of your application, basically. But all of this wouldn't be enough if you don't have something that is more adaptive, because you know that internet is subjected to congestion. So once you want to stream some content, you have to face packet drops, latencies. So you cannot just consider the Komet connection as a tube where you put some data here and want to get them out of there. You have to adapt your transport to the actual conditions of the network. This is what adaptive streaming is. So the server basically should detect if a network congestion exists and throttle the data accordingly. So going back to the example I gave before, say that you are pushing 5 updates in a second for the Microsoft stock quote, but then you have the network congestion. Perhaps you're connected to the Komet server through the iPhone or any other mobile browser like a Nokia browser, and you're moving and the bandwidth shrinks. You cannot send any more 5 updates per second. Instead of giving up, with adaptive streaming, you throttle the data flow and you decide to send 3 updates per second, or 2, or just 1, or just 1 in a minute if you only have 1 bit per second of connectivity. So being adaptive is the key for the success of Komet. Otherwise, it simply wouldn't work. Production scenarios has taught us a lot during these 7 years of history with Komet technology, and we're really confident that this technology is mature. And we see a lot of brand new sites that are shifting their paradigm for traditional polling to real-time Komet. So I encourage you to experiment, to play, not only with Lightstreamer, but with all the Komet frameworks that are available out there. You could download also Komet D, that is a great open source initiative from the Dojo guys. And try to create your own applications, because as another tip, often the companies that owns the site, like banks or betting sites, don't even know about the possibility of doing these tricks and provide this quality. So you can even suggest them and show them some proof of concept showing how they can transform their site into a real-time site without changing the client-side architecture, but rely on HTML and JavaScript. For the ones who are interested in more in Flash and Flex than JavaScript, you can do exactly the same with Flex. There's also a client library based on ActionScript that provide a Komet connection for Flex application so that you can mix them all together. Okay, thank you for your attention. If you have any question, you can reach us at the booth there, or even now if you have time, I'm not sure. Is there time for a question? Okay, try it, go on. Yeah, It's based on a heuristic algorithm, basically. Every second, the server knows how much bandwidth it is consuming, what is the current frequency. So when an update arrives, it's put in a buffer. You can decide the size of the buffer. If the buffer is just the size of 1, so you decide whether to send or to filter out. You don't want to queue them. So if you have enough bandwidth in that moment to send it, you send it. Otherwise, you lose it. Of course, there are data sources where you cannot afford to lose anything. For example, the execution order or a portfolio in a bank. In that case, you subscribe with another mode that prescribes never to filter anything. You will delay the data, but it must receive the user. And if it's filtered out for other reason, you want to send back a notification to the client telling, listen, you are losing updates, what you want to do. So that's why I told that based on the nature of the data, you have to decide what is the best subscription mode with what properties and what behavior. The important thing is to have all the tools that allows you to choose the right behavior. Yes, of course. You could even have different clients subscribe to the same item, seeing different data if you want different resampling frequencies. Okay. Okay.
So what kind of applications, if you build in a financial application and messages are getting dropped?
Yeah.
So how do you end up using it?
Yeah, that's called guaranteed delivery. That's a pretty complex topic. Guaranteed delivery means that for some certain data, you must guarantee that the data reaches the client. Well, Lightstreamer handles this on several layers. First of all, based on TCP, that guarantees the order of packets and the delivery of them. And if the connection simply breaks and you're not receiving any more updates, the client connects back to the server. But instead of simply resubscribing to the same real-time data, it asks for an initial snapshot so that all the updates that were lost during the disconnection are recovered through this so-called snapshot. The snapshot gives the current situation, the current status of the data you subscribe to, and from that time you can start to receive the new data. No, this is done on the server side. The client only maintains the list of subscription it's handling. But when it disconnects, it can empty its buffers, its cache, and only resubscribe to the existing items. This is fundamental for failover. If the server crashes, the client connects to another server and has to restore the session in a very transparent way. So that's actually it's a bit more complex, but we can talk later if you want at the booth. Yeah? Does it support SSL? SSL, yes, sure. You can configure SSL certificate on the server and do SSL streaming. Yeah. Sure. So, suppose you have Tomcat with JSP, right? You keep Tomcat, you keep JSPs, you just add Lightstreamer server, you just change the HTML of your pages to include these JavaScript libraries, you write a data adapter in Java on Lightstreamer that talks to your data feeds, and that's all basically. So you don't change the layout of your application or the architecture. You're just adding something, not changing something. If you have several concurrent users, of course.
How does the session is maintained? Like we use the session object a lot to have all the user information on format.
Yes.
How do you bring that session object into the?
To give you the big picture, the user connects to Tomcat, authenticates. You create a session in Tomcat, you send back some form of session ID to the client, as Tomcat does. Then you will use this session ID to authenticate on Lightstreamer server. Lightstreamer server will send this session ID to your own metadata adapter. Your metadata adapter will close the loop by checking the session ID against your database or against Tomcat. So you don't need to implement a second authentication. It's a single sign-on, and you rely on the same authentication on the web part, even for the Komet part. Okay. I think we don't have any much time. If you have more questions, please join me at our booth upstairs. It's just at the entrance, at the Lightstreamer booth. Okay? Thank you very much.